Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video we're going to be looking at stoichiometry problems. So wait, let me first give you a background on stoichiometry problems and what those are. So we've been talking about the mole and we've been doing a lot with the mole, which is great and all, but we've been only looking at individual atoms and compounds. So in this video we're going to be really looking at chemical reactions and the stoichiometry behind that. So for all stoichiometry problems, this is a basic strategy. First, you balance the chemical equation. Then you change what you have to moles, convert that. Then you use the mole ratio from the balanced chemical equation, which we'll be talking about, and then we'll convert to what is desired. Okay. So let's go ahead and do a few problems so you know what I'm talking about here. So first problem here asks us how many grams of silver chloride is formed by the reaction of silver nitrate with excess sodium chloride, okay, in the following chemical reaction. Alright, so first things first is always balance the chemical equation. So let's see if this equation is balanced. Silver, one silver here, good. One nitrogen here, good. Three oxygens here, good. One sodium, one chlorine, Great, so the reaction is balanced. That's the first step. Okay, always balance the chemical equation. Okay, now this is where we're going to set up our dimensional analysis. So what we're asking for is how many grams of silver chloride. So that's what we're asking for. Okay, and grams, sorry, of silver chloride. And what we have to start off with is 17.0 grams of silver nitrate. Alright, so our first rule is change the known to moles. So what we have is we're going to change this quantity right here, 17 grams of silver nitrate, to moles of silver nitrate. So if we want to do that, we're going to need to know the molar mass of silver nitrate, and I'm going to quickly do that because we've done it so many times that I don't want to have to explain that again. You should get it by this point. So the molar mass of silver is 107.87 plus the molar mass of nitrogen, which is 14.007, plus 3 oxygen, so 15.999 times 3. So that's the molar mass of silver nitrate, so 169.874. Okay, great. So from here we use what's called the mole ratio, okay? So what we're trying to get at here is the question's asking us the grams of silver chloride. So from the reaction here, let's look at what this reaction tells us. This reaction says 1 formula unit of silver nitrate reacting with 1 formula unit of sodium chloride is going to form 1 formula unit of silver chloride and 1 formula unit of sodium nitrate. Okay, so from that you can use you can deduce that 1 mole of silver nitrate reacting with 1 mole of sodium chloride is going to create 1 mole of silver chloride and 1 mole of sodium nitrate. So that's what you get the mole ratio from. So from here, since we're trying to get to grams of silver chloride, the reaction tells us that for every 1 mole of silver nitrate, which is reacting, you're going to produce 1 mole of silver chloride. Okay? And then the last step is to convert to what is desired. So right now we're at moles of silver chloride. So from here we can convert to grams. So 1 mole of silver chloride has a mass of, if you look here on the periodic table, let me go ahead and do the math there, 107.87 plus chlorine is 35.453. So this 143.323. Okay, so excellent. Look how everything's canceling out. Grams of silver nitrate is canceling out with grams of silver nitrate. Moles of silver nitrate cancels out with moles of silver nitrate, and moles of silver chloride cancels out with moles of silver chloride. We're left with grams of silver nitrate. Okay, so now we can go ahead and multiply the top. So 17.0 times 1 times 1 times 143.323. And divide that by what the bottom is, which is going to be 169.874 times 1 times 1. Yes, okay. We get this. Again, we have to always consider our significant digits. We're going to look at this number, and that number. So this has 3, this has 6, and this has 6. So we're just going to make our answer round to 3 significant digits. So the answer is going to be 14.3 grams. So it's pretty simple, really. What you really have to focus on is this mole ratio, which might just trip you up. Okay, that's the really hard part. But other than that, this is really like anything else we're doing. Okay, let's go ahead and do one more problem. So as extra practice. So how many grams of O2 are used to create 10.0 grams of H2O in the following chemical reaction? First step first is always to balance the chemical reaction. So when we balance this, you will get, let me write it up here. So CH4 plus 2O2 yields CO2 plus 2H2O. Okay, first step first is always balance the chemical reaction, because if you don't balance it, then you're not going to get the correct mole ratio, and therefore you're going to get the wrong answer. Okay, then let's set up our dimensional analysis here. What we're asked is how many grams of O2, so that's what we're looking for. And what we're given is 10.0 grams of H2O. Okay, so the first thing we do here is we balance the chemical reaction, and now we're going to change the known to moles. So we're going to have to change this quantity to moles. So in order to do that, we need the molar mass of H2O. And the molar mass of H2O is 18.016 grams. If you don't know how I got that, make sure you check out previous videos because explaining this is going to take a long time, and I don't want to waste anyone's time. Okay, so we're here, and then now we're going to look at the mole ratio from the Balanced chemical equation. So what this equation is telling us is it's telling us 1 molecule of CH4 reacting with 2 molecules of O2 is going to give us 1 molecule of CO2 and 2 molecules of H2O. So from there, we can deduce that 1 mole of CH4 reacting with 2 moles of O2 is going to yield 1 mole of CO2 and 2 moles of H2O. Okay, based on this chemical reaction, since we're looking for grams of O2, it tells us that for every 2 moles of H2O that is created, 2 moles of O2 are used up. Again, for every 2 moles of H2O that's created, 2 moles of O2 are used up. So we can definitely just squeeze that in here. Let's see. For every 2 moles of H2O that's created, 2 moles of O2 are used up. Great. So now we're at moles, and then finally we're going to have to convert to what is desired. So what we are looking for here is grams of O2, so we're going to have to convert this quantity, moles of O2, to grams of O2. So from the periodic table, you'll be able to find out that 1 mole of O2 has a molar, 1 mole of O2 has a mass of 15.999 times 2, 31.998 grams. Then our units are going to cancel out. grams of H2O cancels out with grams of H2O. Moles of H2O cancels out with moles of H2O. Moles of O2 cancels out with moles of O2. And we're left with grams of O2. Okay, now that we're there, grams of O2 is what we wanted to start off with, so that's good. We can go ahead and calculate, so multiply the top, so 10 times 1 times 2 times 31.998. Okay, divided by the bottom, which is 18.016 times 2 times 1. Which is going to give us this, and our answer needs to be rounded to 3 significant digits because this number is an exact number. This is also an exact number because we know from the chemical reaction exactly 2 moles of O2 is going to be used up to create 2 moles of H2O, so we don't look at these numbers. And this number is also an exact number, 1 mole of O2. So we're going to only be looking at this number here, 10.0, 18.016, and 31.998, because those are estimated numbers. From there, this number has 5 significant digits, this number has 5 significant digits, and this number has 3. Therefore, our answer needs to be rounded down to 3 significant digits. So when we do that, 17.7608 is going to be rounded down to just 17.8. So 17.8 grams of O2. Okay, let's do a last example here. How many moles of Cl2 can be formed by the reaction of 1.5 times 10 to the 22nd F2 molecules in excess KCl by the following chemical reaction? All right, so first things first, balance the chemical equation, okay? So when we balance it, I think we put a 2 here, and then we put a 2 here. 2 fluorine molecules, 2 potassium molecules, 2 chlorine. Okay, so it's now balanced. Great. That's pretty simple. Sometimes it's already balanced for you. Your teacher might be nice, but if it's not, just make sure and check it is, because a lot of people lose points here, get the completely incorrect answer just because they didn't check to see if their equation was balanced. Okay. So it is balanced. Now let's go ahead and set up a dimensional analysis. So what we're looking for is moles of Cl2. What we have is 1.5 times 10 to the 22nd molecules of F2. Okay. So step says here, change the known to moles. So we want to convert molecules of F2 to moles. So in order to do that, we know that 1 mole of any molecule is 6.022 times 10 to the 23rd. So 1 mole of F2 is 6.022 times 10 to the 23rd molecules of F2. Excellent. Okay, from there, use the mole ratio. So what we're trying to get at is moles of Cl2. Our reaction tells us that for every 1 mole of F2 that is used, 1 mole of Cl2 is created. So we can use that as a conversion factor. 1 mole of F2 which is used up, 1 mole of F2 that's used up, 1 mole of Cl2 is created. Excellent. And then last step is to change the what we have to what we desire, and we desire moles of Cl2, so we don't need to have one more step here. We're exactly where we want to be. So molecules of F2 is going to cancel out with molecules of F2. Moles of F2 is going to cancel out with moles of F2, and we're left off with moles of Cl2, which is what we originally wanted. So let's go ahead and now multiply. So 1.5 times 10 to the 22nd, okay, times 1 divided by 6.022 times 10 to the 23rd power times 1. So 6.022 times 10 to the 23rd. It's going to give us this. Great. And then from here we can look at our significant digits. So the only number that is estimated here is this number and this number. These numbers are all exact numbers. So we're going to look at this. This number has two significant digits. This number has 4. So we're going to go with 2 here. And our answer needs to be rounded down to 2 significant digits. So in order to do that, we will round this down to 0.0025. Wait. 0.025, not 0.00. I might have said that. Yeah, 0.025 moles of Cl2. Okay, so it's pretty simple, okay? A lot of teachers have a tendency to just make this more complicated than it sounds. You know, all you got to do for these basic stoichiometry problems is just follow the strategy that I've used here, and you're going to be good to go. All right? You know, as you can see, stoichiometry and everything we've been doing here is just essentially just conversion factors, just like how we were converting units way back in the first unit, converting between, like, you know, meters to millimeters and things like that. This is essentially just converting things. That's all this is. And once you realize that, and once you get the hang of it, you're going to be really good at this. I hope this video helped. As you can see, stoichiometry problems are as simple as that.